Hi everyone. So I'm going to go through your Project 4 rundown and kind of how to get started for it. Your Project 4 is essentially a Pac-Man game, and you are implementing the logic for your Pac-Man in order to achieve the highest score. Okay, so how do you get started? First is first. This project uses an existing codebase on a Git repository that you can clone that repository with the URL, this following URL that is on your project instructions in Canvas. Now, how do you clone this? I'm going to show you the first way and then the second way really quickly. The first way is you open IntelliJ to its home screen and you see these four options. You choose checkout from version control, you click on that, and then you have these three sub options appear. You click on Git, and once you click on Git, this pop-up is going to appear, and in the URL field, you're going to paste the link that is in your project instructions. Once you paste that link, you don't really have to modify your directory. It should look very similar to mine. And then you're going to press clone. Once you do that, this next window is going to appear, and you're going to say yes, check out from version control. So before I continue, another way that you can do that same thing, I'm going to show you really quickly, is you go up here and you go to New, Project from Version Control, and you press Git as well. And then you have that same window appear that was on your third step. Yeah, third step. And you press clone, and then it will tell you to open in this window or a new window, and you can also do it that way, whichever one you prefer. Okay, so once you do that, you are going to have an existing codebase in your IntelliJ window, and when you open your SRC folder, you're going to see all of these. The only place that you are going to add code in is the Student Attacker Controller class. That's the only place. The Student Attacker Controller class has three methods: an shutdown, an initialize, and an update. Shutdown and initialize are optional depending on how you decide to implement. And then the update, you have to include code in there, and that's where the majority of your code, or all of it's going to be in. Now, you can see that you have interfaces and classes that implement the interfaces. You can, if you open one of the classes, and I'll show you guys really quickly, you will see that at the top it says actor implements actor, because it implements the actor interface. And then let's look specifically, for the interfaces, I included a definition and a link if you guys are still confused or want just to further understand. I would check it out. I think it's a useful link with some examples. Okay, so looking at the interfaces, we have an actor interface, an attacker interface, a defender interface, game, maze, and node. So what does that all mean, right? Let's look. So, an actor. An actor is basically one of the characters in your game. In this game, you have two types of characters. You have an attacker or a defender, but they're both generic actors. Does that make sense? So if we look at our code that when we cloned we'll have, if you go into the attacker, you can see it says attacker extends actor, and defender extends actor as well. So that being said, now we know that each attacker and defender has a location, a specific location at a given time, and each pill and power pill also has a location. In this game, a location is defined by a node object, and each node has an X and Y coordinate. You can see that by opening up the source code, but yeah. Now, the two types of pills that you have a normal pill, which is a small one, and it increments your points as you eat them around the maze. And then you also have a power pill, which is the big ones. The power pill, as soon as you eat one, your defenders turn blue, and you can eat your defenders, which gives you a good boost in your score. So those are the two different types of pills that you have. And remember, a pill, a power pill, a defender, and an actor, they all have locations defined by a node object. Okay, moving on. In your project instructions, you have a breakdown of the different interfaces and the methods that are implemented in their respective classes. I'm going to just go over very briefly the game interface as an overview, but I want you to go over all of them and kind of do the same that we're going to be doing here. So if we look on the game interface, we have these are not all the methods, but some of the methods that you can use. You have get pill list, get attacker, get defender, and underneath each of the names, it gives you a description of what that method should do. If we look on the right-hand side, we see that we have the update method. This is the method that is in your student attacker controller. And it's the method where you're going to implement most of your code or all of your code in. Remember, shutdown and initialize are both optional depending on your implementation. Now, if you see an update, you have a game object being passed in the parameters. And this game object is called game. How do I know it's a game object? Well, you look at to the left of the name, and you can see it has game. Okay, so now looking at the code, this code here is already there when you clone it. It's given to you, right? But this code uses randomness. And one of the requirements for your code is that you cannot have randomness. So make sure that you take this out. But for now, I'm going to use it just to show you guys kind of how this works. So if you see in this code, you have game, which is your game object, .getAttacker, which is a method that is in your game interface. Now, it makes sense that you're calling getAttacker with a game object since it's in the game interface, right? So in order to use the method getAttacker, you need to call it using a game object, in this case called game. Now, think, what does the getAttacker method return? If we look here on the left-hand side, you have the method signature. And you can see that the return types are to the left and in blue. So what does it return? And why can you call the method getPossibleDirections abbreviated using what the getAttacker returns? So how would you answer those questions? For the second question, I would go into your project instructions and look, hey, under what interface is getPossibleDirections under? So then that can give you an inkling of what object or what you need in order to call it in your code. And then think, oh, well, why does calling game.getAttacker and using whatever that returns to then call getPossibleDirections work? Okay, so start thinking like that when you start reading the instructions and seeing like how everything kind of connects in a way like that. So again, that's kind of my recommendation. Look at all the whole summary at the different interfaces, the different methods available for you, and start looking, okay, I like this method because I think this method could help me achieve blank behavior for my attacker. Now think, what do I need in order to call this method? And what does this method return? And how can I use what it returns to my favor? Now, note that the list on your project instructions is not exhaustive, and in order to see all the different methods that you have available, you have to open the source code and look and read through it. Okay, so I want to briefly touch on the list interface just in case you haven't seen this notation. In a lot of the different interfaces and class implementations, you're going to see a return type like this: list defender, I'm not sure, but list attacker, let's say, etc. So what does this mean is that getDefenders returns a list of defenders. Now, also the Get Defenders method is part of the game interface. So think like, how can you call the Get Defenders? Like, what do you need in order to call it? And since it returns a list of Defender objects, how are you going to use that, what it returns? Or if you don't want to use it immediately, what do you have to save that into in order to use it in the future of your code? I included a list that has useful Java examples for a list interface, and this definition is also part from that link. So if you're still confused, you can't click on it, but I would go to this link and read on it a little. This following screenshot is also from there, and this just shows you a notation of how you can create a list in this form. Okay, now running your code, you have different options. At the top bar of your IntelliJ, you will see that if you click on this drop down, you have all of these options. I'm going to talk through a few of them. So if you run your code with the human visual option, what that does is it allows you to manually play the game with your keyboard, and I'm going to do a demonstration of that at the end. The second one is Test Agent Visual. What that does is that it allows you to visually see what your code is doing during one game. So you can press play with that option and take your hands off the keyboard, and you would see the attacker move depending on your code. So you can kind of see, engage like what your code is doing. Is it working? Is it not? And that's just for one game. Then for the third one, the Test Agent Score, the one that's the most important one, in my opinion, runs your program for 100 tests, trials 0 to 99, and it gives you the score for each game. And then at the end, it gives you the average score. This average score is the score that you need to make sure is above 6,400 points in order to achieve full credit. Now, the fourth one is Test Agent Debug. It's very similar to Test Agent Scored, but it just does 5 tests instead of 100, and then it gives you the average. Since Test Agent Scored might take a bit long, well, it takes longer than the Test Agent Debug. That's why Test Agent Debug might be useful, but keep in mind that the average that appears in Test Agent Debug doesn't necessarily correlate with the one in Test Agent Scored. The Test Agent Scored average can be either higher or lower, just depends. So this is a snippet of your Test Agent Scored output. It's going to be pretty long. It's going to start at trial 0 and go all the way to trial 99. And then at the end, you're going to see this average score. And remember, this is the average score that needs to be greater than 6,400 in order to achieve full credit. Now, last thing that I kind of want to point out on this PowerPoint is keep in mind these requirements. Remember that your student attacker controller class is the only place where you're adding code. And that class has 3 methods. It has an initialize, a shutdown, and an update. The initialize and shutdown can be optionally left empty. The update has to have the majority or all of your code. And then also remember the attacker's behavior may not be random. So what does that mean? The code that comes when you first clone it, this snippet here, this is random. So you want to make sure that you take this off when you start implementing it on your own, because this is not allowed for your project submission. Okay, so now that being said, I'm going to show you guys the test agent, the human visual, and how that works. So you would go over here, make sure you have human visual, and press play like I just did. Okay, so it just popped up, and now you can see my gator here. I can, with my keyboard, play and move around as I want. When they're blue, I would be able to eat them, like I just did. And blue, you get them to be blue by eating the power pills, which are the bigger pills. I'm just moving around here, but essentially, I'm gonna let myself die now. Essentially, this human visual, in my opinion, is very useful in order to see what would be your strategy in order to maximize your points. points when you were playing as a human. And once you have that strategy, try to prioritize it and say, when I play, I first try to do this, and then I try to do that. And if there's no more whatever, then I'll do this. So kind of have that logic that you are doing unconsciously, probably, as a human. I would write it down. And once you have that written down, go back to your project instructions and start thinking, okay, how can I implement this strategy with the methods that are available to me? And once you start figuring out which methods are going to help you out with your implementation, make sure then in the update method here, you are going to put all of that in the sequence that you want. So one of the really cool things about this project is that there can be many implementations. There's not one correct way. There's a lot of ways to achieve the points, your score being higher than 6,400. So be creative and think outside the box and go into the source code and start looking into it and seeing like, oh, like this is how that works, and try to understand a bit more on that side point. Okay guys, so now we're going to go into a bit more about the useful methods that the existing codebase provides for your use. So the first thing I want to re-emphasize is that where you're going to be putting code in is in the Student Attacker Controller class. And in that class, most or all of your code is going to be in the update method. You also have the shutdown and the initialize, but those are optional implementations, depending on how you want to implement this whole thing. So talking specifically about the update method, the update method returns an integer, and this integer is called action. And what does action represent? Action represents the direction that your attacker, so your little gator, is going to go in. So you have up, right, down, or left. But as you can see, action is an integer. So these directions are mapped to their corresponding integers. Now, your code here before you return action is not going to be probably just action equals 0. So you want your attacker to just go up. What you're going to have in your code is that you're going to leverage all the different methods that are available for your use to define or to get different actions, but that are dependent on the game's status in real time. So as the defenders move around, your actions change. As if you already ate all your power pills, well then your action also changes. So it's just having all these different conditions with the use of the methods in order to get the next direction that your attacker, which is your gator, should move in. So just to show you guys a little, the class direction defines these final integers, up, right, down, left, empty, with their corresponding integer values, and it's in the game interface. So if we were wanting to use this, we would be able to save it into your action variable, and since it's in the game interface, you would use the game class. You would put direction, and then you would see you have down, left, empty, right, up with their corresponding integer values. If we just did down and we left it like this would make your attacker go down. And this is essentially just saying action equals whatever down is, which is 2. Okay, so after we understand that, we're going to start going into more specific methods. So the first one that I want to talk about is in the game interface, and it's called GatorRaider. So when we start talking about these methods, I want you to think, okay, what do I need in order to call this method? Since it's a game interface and it's a non-static method, I need a game object in order to call GetAttacker. Okay, I know that. And then what does this return? This returns an attacker's attacker's actor object, so an attacker object. Why is this useful? You'll see that as we go on, just as we have a game interface, there's also a actor interface and an attacker interface. That in order to use the methods inside of these interfaces that are implemented in their respective classes, you're going to need an attacker object in order to call them. So again, as a reminder, your attacker is your gator. It's the character that you are controlling with this code. You have one attacker and 4 defenders. The defenders you don't control. You're just controlling the attacker. So this is how you would do it. So you would need to create a variable that's an attacker object and then set it equal to whatever the method returns. And remember, we're using the game object, which in the update class is passed in as a parameter in order to call getAttacker. Okay, moving on. So the next one is in the actor interface, and it's called getNextDirection. So before we start going way more into it, I just want you to think, okay, what do we need to call this method? Since it's in the actor interface, we need an actor object, and that can be either an attacker or a defender, right? But since you are controlling your attacker, it would most likely be an attacker because you're finding the next direction for your attacker. So that's why you want to call this method on your attacker object. Now, what do you need to pass into this method? You need to pass in a node and a boolean. What is a node? A node is, if you remember, it's a location. Okay? And then what does this method return? This method returns an integer. And by just the name of it and reading the description, it says it returns the next direction. So it returns an integer that represents a direction. If we remember, we covered that up here. So these are what it's returning. So it's returning something that you could save into your action and then later on return your action. Okay? So again, what is a node object? A node object is a location. What can have a location? In this game, you can have an actor. An actor can have a location, and an actor can be either a defender or an attacker. A pill and a power pill can have a location. So those all have a node specific to them at a given moment. So the method functionality, why this is useful, it's that you can choose a node. So that's the node that you're going to be passing in. So it could be the location of a defender, a pill, or a power pill. And get the direction. So action, so remember those integers 0, 1, 2, so on. For the actor, in this case probably an attacker, you are calling the method on. And you can decide, and that direction is going to be chosen by either the boolean being true, so approach, or false, flee. Now, if we start thinking, when would you want to use this? It's as an attacker, when would you ever want to flee a defender? So maybe when the defender's close to you, you want to be able to get the location of that close defender, pass it into this method, and for the boolean, put false to flee because you want to go away because you don't want to get eaten. Right? Okay. Moving on. The next one is also in the actor interface, and it's called getTarget. So let's talk about this again. What do you need to call this class? You need an actor object. What do you need to pass into this method? You need a list of nodes this time, and a boolean. And what does this method return? It returns a specific one node. So what does this do? It's that you need, in order to call getTarget, you need an actor object, right? So our attacker object. So if we call getTarget on our attacker object and we pass in a list of nodes, which are locations, and we put the boolean to be true. What it will return is that it will return the node from this list that is the closest to our actor, in this case attacker object. Okay? So if we're trying to connect things, what was one of the parameters of the getNext direction method we just talked about? One of the parameters was a singular node. And you can see that getTarget returns a singular node. So there could be some connection there in that if we're given a list of nodes and we want to find either the closest or the furthest, well then we will call getTarget, and then we would use getNextDirection by passing in whatever that returns, and a true or false depending on what we want, to be able to get the next direction as an integer for our attacker. Okay? So we already talked about this a little bit, but this is an example. So hypothetically, if you have a list of locations of your power pills, so at the start of the game, I think you have 4 power pills. So let's say we have 4 locations. You would be able to find which power pill is the closest to you being the attacker, which is an actor, and then return the location of that closest power pill. And this can help you in your code depending on how you're gonna implement all of this. Okay, the next one is in the game interface this time, and the next 2 are both in the game interfaces. So if we're thinking about it again, what do we need to call? What do we need to call these methods? Well, we need game objects. Now, what do you need to pass into these methods? They both have no parameters, so nothing. And then what do these methods return? These methods return a list of nodes, and nodes are locations. So it's pretty self-explanatory that getPowerPillList will return a list of your locations for your power pills. And then getPillList will return a list of locations, which are nodes, for just your regular pills. Remember, if we go back here, the example that we were using takes in for getTarget a list of nodes, right? Which here now we're returning a list of nodes. So to further connect that, what is one of the parameters of the getTarget method? It's a list of nodes. So we can see that both of these return a list of nodes, so we can also leverage that through there. Okay? Now, these other useful methods. Let's start with getDefenders. So before we were talking about these getPowerPillList and getPillList, which return a list of nodes, which are locations. But now this one, getDefenders, will actually return a list of defender objects. So this isn't the location, this is just the object. So remember, defender object is it extends an actor object, right? But now, knowing that, okay, what if we don't want just the object, but we actually want the location, so the node of a defender? Well, that's when you would connect this getDefenders. So you would get the list of defenders, and then for each of those defenders, if we wanted to get the locations, we would have to call individually getLocation on them. So you can see that getLocation is part of the actor interface. So you need an actor object, which one of the actor objects is a defender object, so it works well with this. And you have no parameters, and it returns one specific node, which is the current location of the actor that you use to call this getLocation method with. Okay, and then this one, it's in the defender interface, so you need specifically a defender object in order to call it. As you can see, we just talked about this one, getDefenders, and it returns a list of defender objects, so again, that's where this connection may be. And what you would do here is that with isVulnerable, you would call isVulnerable with a specific defender object, and it would return true or false depending if the defender is in a vulnerable state. And what does in a vulnerable state mean? Defenders become vulnerable whenever you as an attacker eat a power pill. And if you play the game visually, you would see that the defenders turn a different icon and it's like blue. Okay. So now that I went through those, I want to go into the GatorRaider project instructions and show you all the other ones that I didn't talk about. I'm not going to go super in depth with them because I want you to do the same exercises that we kind of did with the ones that we went one by one, but for you all to do it. So we talked about get defenders, right? That it returns a list of defenders. But let's say hypothetically you don't want the list, you just want a specific one. Well, then you can see right above it, we actually have a get defender. And you have to specify in the parameter with an integer which defender, and it will return an object of that specific defender. Okay? If we keep going, in the node interface, you'd see you have one that's called get path distance. And it returns the distance of the shortest path between this location and the destination. What does this location mean? It means the node, since this is a node interface, you need a node object in order to call get path distance. So this location is the node object you're using to call get path distance, and the destination is the node object that you're passing into it. So if you're a bit confused on one of them and you're like, okay, I understand what they're saying here, but I kind of want to see more in depth what it does. You would be able to go into your code and say, okay, we know that that's in the node class, right? And then you would search for where you find, I get next direction, but get path distance. And you can see that here it's actually calling this. So you would then, if you want to, you would go into maze. But then an interesting thing is that you can see if the result that is returned from here is null, then it would return -1. So you now know that get path distance, one of the possibilities is -1 if for some reason there is no distance, the distance wasn't able to be found. So that's interesting to keep in mind when you're implementing. Now that you went into the source code, you were able to realize that. You can do that with all the other methods that are here as well. Okay, so then you have a maze interface that I didn't really touch on that much. But this one, which is get pill nodes and get power pill nodes, they're very similar as well to, if we go up, and we did talk about this, the get pill list and get power pill list as well. Okay, so then just you can keep looking at all the different possibilities that you have in all of these, right? And remember that for defender interface and attacker interface, for both of the, like an attacker object and a defender object, you will be able to use any of these methods as well on those objects, since an attacker and defender, they both extend actor. So now that I've gone a bit more in depth with specific ones, I think you guys are in a good place to start. I recommend to keep thinking about it with these 3 questions and trying to then see how other methods that you've already read about fit in with this new method that you're learning about. Go into the source code, look for things if you're confused and whatnot, and don't be discouraged. This isn't necessarily, there's no right or wrong necessarily. Sometimes you're trying things and your score might go down, and it's not that you're not understanding it, but it can be a lot of things. It's just not, you have to understand the source code, which can be pretty difficult at times. So be patient, try different things, and really think it out. But have fun, and yeah, be creative. And remember, you can go to office hours via Zoom to ask any questions, All the TAs are more than happy to help.